exponential functions. We're going to use this example to explain what an exponential function is and how you find values for it, how you graph it. So suppose at time t equals 0 hours, there are 3 bacterial cells in a petri dish, and the population of bacteria doubles every hour. Find the exponential function p of t that models the situation, graph the function, and find how many bacteria cells will be present at t equals 10 hours. So we're going to make a little chart here to explain what's going on. Here's the time in hours, here's the population of bacteria. At 0 hours, it said there was 3. At 1 hour, there was double that. So it doubles every hour right there. It could triple, it could quadruple, but this one's doubling. So 3 doubles to 6. After 2 hours, it becomes 12. 3 hours doubles that to 24. 4 hours doubles that to 48. Now, in order to get a formula for this, we have to break it down. So when time is 0, you just have the 3. Then you double the 3, 2 times the 3 to get the 6. And then when you're at the 6, you double that to get to 12. And when you're at the 12 right here, this is 12, you double that in order to get to 24. And when you're at 24, which is 3 times 2 times 2 times 2, that's 24. You double that to get to 48. So there seems to be a building up of factors of 2, and that sounds like some kind of an exponent. So if we simplify this down, the 3 is 3 times, well, it hasn't doubled yet, so 2 to the 0 power, which is 1. So 1 times 3 is 3, so it's okay. Then after 1 hour, it looks like it doubles once. That's how you get to 6. So 2 to the first power. And there's one factor of 2. 1 factor of 2. Another way to see this is that there's 0 factors of 2 multiplied here, so 0. Now here you have 2 factors of 2. 2 to the second power. Here you have 3 factors of 2. And here you have 4 factors of 2. The factors are building up every hour that goes by. So when you look at these, now you see that there's a formula happening here. The population at time t is definitely 3 out in the front times 2, that's the base, 2, well, it's the same. If it's 4, it's 4. If it's 3, it's 3. The 2, it's 2. So it's the t. So this is your population function. It's called exponential because the variable's in the exponent. The basic exponential function form is y equals a times a base to the x power, where b is greater than 0. That's your form. Now we're supposed to graph it. So let's graph it over here. And we're going to take this list of points right here, and we're just going to graph them. 0, 3 graphs here. 1 graphs to 6. Might have been a little high there, but that's okay. 2 goes to 12. Is 12. 3 goes to 24. That's 24 right there. And 4 goes to 48 up there. And then we continue on going up. See that the function is exploding. Exponential functions explode going up here when the base is greater than 1. Okay, and now we're going to fit this with a curve. Okay, so there it is, drawn through there. It's a little bit warbly, but it's supposed to be very smooth. Okay, and then we're supposed to find out how much bacteria is in there after 10 hours. So here's your 10 hours. Plug it into the function right there. 10 hours. get the calculator out, go 3 times, and on the calculator you go 3 times 2 up arrow 10, enter, and it gives you 3072. So that's the answer there. Now let's see what it looks like with the calculator. For the calculator method, you put in your function. We have to use x because that's the way the calculator wants to see it, because t is reserved for parameters, which is something else. So we just have to use an x. This is the window I used. I had to cover the 3072 and the 10 that it went up to. It could have gone a little farther. I'm doing the negative and the negative here just to show where the 0 is on the axis here. So anyway, this is what the window I used to get this picture here, and of course this is P of t and t hours. Okay, and then if you want to evaluate at 10, you just do second calc value and put in x equals 10 and then enter, and it tells you the answer. There's the answer, and it blinks at the point right there where it is on the curve.